What up, what up? I'm the math teacher Goat, and today we are doing a full lesson on AP Precalculus 3.7 Sinusoidal function context and data modeling. Lots of calculator stuff, lots of word problem stuff, lots of fun. Make sure you go to the description, download the notes, print them out, follow along. Make sure you like and subscribe. Let's get right into it. Stuff that we did in the previous lesson is graphing. So let's compare this to the good old regular way of graphing a sinusoidal function using cosine. So it's a cos b parentheses x minus c, close it, plus d. And we've got everything going on here. We have an amplitude of 2, all right? We have a frequency of 1/2, which we need to help us find the period. So, what did I write out that there? Say that the amplitude was 2 and never wrote it down. Silly me. Frequency is 1/2. So the period is going to be 2 pi over 1/2. Multiply the top and the bottom by 2. Oh my goodness. You get a period of 4 pi, which I will barely be able to write any of that. What else? We've got a shift to the left, no, to the right of pi over 2 and move down 1. All right, so let's move right pi over 2 by making that line right there. Let's move down 1 by making that line over there. And we now have a new origin that lives right there. Now we have a regular cosine. The amplitude is 2, means that peaks out here at 1, and it's going to bottom out at -3. Okay, now here's the issue that I don't have. This is supposed to repeat every 4 pi. I don't have 4 pi to repeat. So what I have to do is it goes half the way every 2 pi. So if it's going to peak out up here, it's going to bottom out 2 pi later. So I could put a dot right there, which means halfway it's going to cross. So every pi it's going to cross. I really don't have the space over here, so I'll kind of force it right there. And I'll kind of force it right there. So I can kind of draw a picture. I really didn't do a good job choosing a graph for this when I chose it. But you know what? Worked out anyway, even though I'm not a fan. The table on the right represents a sinusoidal function. Sketch a graph. All right, looks like all the actions happening in quadrant number 1. So 0, 1, 2, going up to 10, 4, 5, 6, 7, 8, 9, 10. Oh my goodness, I'm dealing with a bit of a cold, so sorry everybody. We'll put 1 there, we'll put 5 there, we'll put 9 there. So those are going to be our primary points that we're dealing with. 0, 9, right there, looks like it's going to be cosine. 1, 5, 2, 1, 3, 5, 4, 9, 5, 5, 6, 1, 7, 5, 8, 9, 9, 5, 9 to 5, that's no way to make a living. Dolly Parton. 10, 1. All right, so very cosine. Very cosine. Sketching a graph. Sketching a graph. Maybe I get a nice 7 out of 10 for that one, which I'll take for me. All right, amplitude is half the total height. So 1/2 of 9 minus 1 is going to be half of 8, which is 4. Makes sense. The period is how often it repeats. So if I say the tippy top is right here and then the tippy top again is right here, that goes from 0 to 1, 2, 3, 4. So the period is just going to be regular old 4, which makes the frequency 2 pi over the period 4, so pi over 2. It's going to be my frequency. My midline appears to cut right through 5, so y equals 5. This looks like it's a cosine, so I believe the next part is write out the equation. It sure is, but we're going to do both sine and cosine. So we'll start out with the cosine first and then turn it into sine. So the cosine version of this would be, and we're comparing it to y equals a cosine b x minus c, close it, plus d. A is my amplitude, amplitude, and that happens to be 4. Cosine. B is the frequency, which we said would be pi over 2. Now this would be x minus 0 because there's no shift left or right. So we'll just put x there. Then we'll close it. Midline is 5 plus 5. Now how can I easily turn this into a sine function? Well, there's a little rule that says that cosine x is the same thing as sine pi over 2 minus x. So I have y equals 4, and I'll turn cosine pi over 2 into sine by doing sine pi over 2 minus pi over 2x. Okay, since that is like technically my whole x, I'm writing that out as pi over 2 minus pi over 2x. And then plus 5. And if I wanted to simplify this further and factor out a pi over 2, I guess I could, but I think I'm okay. All right, let's do some word problems. I'm going to show the whole thing, and we got calculator stuff at the end there. Ugh. All right. Okay. A student rides his bicycle to school each day. The pedals are mounted on the bracket whose center is 29 centimeters above the ground. Each pedal is 16.5 centimeters from the center of the bracket. All right, so let's draw a bit of a picture. Okay, you got something with pedals on it. Okay, so that's a pedal, as you can see. And I know I should have kind of made it so that it's at the very tippy top. That's all right. I think we'll all understand. It hovers at, the center was where? 29 centimeters above the ground, which means the very, very, very tippy top would be 16.5 above it. So 29 plus 16.5 is going to be 45.5. And then the very bottom of it is going to be 29 minus 16.5, which is going to be 12.5. I think we're good. Each pedal, assume that the bicycle is pedaled 12 cycles per minute, so that is our... Well, 12 cycles per minute is okay, so we'll discuss that in a minute. With the starting position of the pedals, horizontal position, t equals 0. Horizontal position means the center, so we're starting at 29. So what I need to do is I need to label this. Label the graph x with time, so each line will represent 1 second. Okay. So 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, 15, 16. All right. Label the y-axis. We're doing 5 centimeters, so 10, 15, 20, 25, 30, 35, 40, 45, 50. All right. So what do we have? We have a midline of 29. So midline's going to be right here. Okay, midline's going to be right there. But what I need to understand is if we pedal this 12 cycles per minute. So 12 cycles per minute means we're going to have a period of 60 divided by 12, which is 5. So my period is 5. So it takes 5 whole seconds for this guy to spin the pedal around 1 whole time. So this guy's going at 3 miles an hour downhill. So we start out at the center at 29, and then we repeat every 5 seconds. So 29 again here at 5, 29 again here at 10, and then at 15, 29 yet again. Okay, let's lower you just a teensy bit. Okay. Now what this means is he is going, does it say counterclockwise? Sketch the graph is not a sort of function of the reason. Assume the pedal you are measuring goes up the first rotation. So we're going up, down, back. So halfway through, it's going to be 29 again. Halfway through, 29. Halfway through, it's 29. Halfway in between that, we hit our peak at 45.5. So right around there. Halfway in between here, boy, this is unpleasant. We bottom out at 12.5, so right in the middle. Okay. So halfway in between here, right around there, right there. Halfway in between here. So it's going to be like right around there, 12.5. Halfway in between here, right there, 45.5. And then last but not least, halfway in between here, right around there, 12.5. All right. So let's draw it best that we can. Just, drawing. Not really much to talk about. It's just we've done enough of these graphs that we kind of know what's going to happen here. All right, so that is our graph. Very siny. Very siny. And in fact, that's what we're going to do next. Write the equation of the sine curve with the given time in seconds. All right, so what we know is if this is a sine function, y equals a sine bx minus c, close it, plus d. My amplitude is already given to me by the fact that it tells us it's 16.5. So right now I have y equals 16.5 sine. Okay. What I don't have is my frequency, but I have my period, and so frequency is going to be 2 pi over my period. So 2 pi over 5. We're not shifting left or right, so I could just put minus 0, so just regular x will come along for the ride. And my midline was 29, so plus 29. So let's use that equation a couple times to answer both of these, and we'll do them both in one fell swoop. We'll do them both, and we'll come back and write them both down. All right, good old calculator stuff. You know I hate it. Whenever we're doing sinusoidal functions, it's very important to make sure that your mode is in radians, and it appears to be, so that's good news. It always is when it's in its reset form. So now it's just a matter of graphing this guy and answering those two questions over there. So we had 16.5. It was sine, which is u. And then we had 2 pi over 5. So I'm just very paranoid. I'm going to throw in parentheses and do 2 pi is second caret looking thing over 5. So now it's its own parentheses. X, close it, plus 29. So if I wanted to see the graph, it's not going to give me a lot the way it is. In fact, it's not going to give me anything. And if you're like, why? Well, if you remember, the midline was 29, and it dipped down to its lowest at 12.5, which means we're not going to see anything. So we could zoom. Let's do zoom. I don't think zoom stat would do anything now. So we kind of just have to make up our own window. So if we just remember, well, let's do this. Let's zoom trig. And what that does is that gives us pi's. Although I don't want the pi's because these are normal numbers. I'm just talking out my butt. Let's just make our own window. Okay, let's make our own window. Our x-min, since this is a real life object, will start at 0. The graph that we drew is 16. So why don't we make it to 16? The y minimum was 12.5, so we'll keep the y minimum at regular 10. Okay, and our graph, the maximum was, what was it? I don't remember. It was like 40 something, so maybe if we leave it at 50, I think we'll be okay, and we'll always come back and check. There we are. So that worked out just fine. Now, E asks, when is the pedal 4 centimeters above the ground for the third time? So let's type out 40 into a second one, 40, and graph it. So first time, second time, third time is right there. So let's find out when they intersect. Second, trace, intersect is going to let us do that. So let's make sure that our little cursors are right where we need them to be. Put it just to the left of that one. Put it just to the right of that one. Always hit enter for guess. And we're looking at 5.5006. So we could say 5.5 seconds or 5.500 seconds if we're doing the 3 decimal trick. Or is that an 8? I hate having terrible eyes. This is not me getting my phone out and zooming in. It is an 8. Oh, trickery. All right. Okay. That was E. And so we're saying 5.580. F is asking us how high is the pedal after 23 seconds. So here's the thing. We only moved out to 16, so let's change our window to X max of 25. All right. We don't need this second equation anymore, so let's get rid of it. Clear, clear. And we'll do second, trace, and put in our value at 23. Now, why did I have to extend my graph? Because it won't let us do anything. Uh-oh, did I do something wrong? I did. Second calc, value, enter. It won't let me do it unless I could see it on the graph. So that's why I had to move it out to whatever I did. So I'm going to type out 23, and that gives us 19.3015, so 19.302, and that should do it. So when is the pedal 40 centimeters above the ground for the third time? That was 5.580 seconds. How high was it after 23 seconds? That would be 19.302 centimeters. And that one is that one. Great. Use a graphing calculator to find a sinusoidal function that matches the data below. So we are going to do sin reg, which is sinusoidal regression. It's lots of fun. You ready? All right, sinusoidal regression is just like any other regression. You go to stat, edit, and you just start typing away. Our x values are 0, and then the pi button is right there. So 1 pi, 2 pi, and we're doing this all the way up until 9 pi. Ugh. All right, well, feel free to fast forward, because this is going to get pretty boring. Just me typing in a bunch of numbers like that, hoping I don't make a stupid mistake. Fun fact about me is I love cats. I have a picture of a cat tattooed on my left leg. All right, we're done with X. Now we just type out numbers, hoping I don't make a mistake. 3, 4, 9. I have to pay a little bit more attention to these. No cat stories for this one. All right, 3, 4, 5. So the numbers are kind of different. So they're a little iffy on purpose, which is fine. Only God is perfect. Comment if you agree. Uh-oh. Uh-oh. That was a close one. 2, 3, 5. All right. I'm looking at this, and I think I got it right, and I don't think I made too many typos because I accidentally made a typo, and I didn't. I think I'm good. All right. So, stat. For what we're doing, I don't need this equation for later, so I'll go to stat, calc, Sinusoidal regression is towards the bottom, so hit up a few times to see sin reg. Okay. Don't worry about any of these. This is just useless. I don't know why it's there. But we're just going to go straight to calculate, and it's a mess. So when we write this out, we are going to write out, they wanted f of x, so f of x equals 167.151 sine parentheses. Now notice that this is not the traditional way that we do it. This is just their version of it. So don't be like, what about the double parentheses and the minus sign? Baby, we're just writing out what they have us write out. So 0.249x minus 3.123. And then close the parentheses and add that number 346.864. So not the prettiest picture, but we did it, so let's go back and write it out. Okay, so let's just write this mess out. For f of x equals 151 sine parentheses 0.249x minus 3.123, close it, plus 346.864, robot voice. Yuck, yuckity, yuck, yuck, yuck. And that's not me laughing, that's me just saying gross. All right. You see this problem on basically every practice test for the FRQs. They love a problem that looks like this. The FRQs love these, so I'm using it, stole it. Mr. Sullivan is tired of not having an air conditioning in Germany. I'm sorry, Mr. Sullivan. So he buys a large fan for his living room. The blades of his fan rotate in a counterclockwise direction and complete 20 rotations every second. I wonder if that's accurate. Point P is on the tip of one of the fan blades, like so, and is located directly above the center of the fan at the very beginning. So it starts at the top. Point P is 12 inches from the center of the fan. The center of the fan is 30 inches above the ground. So you would be 30, you would be 42, and 30 minus 12 would make you 18 inches above the ground. The center of the fan. As the fan blades rotate at a constant speed, the distance between P and the floor periodically decreases and increases. We know because it's like, so it looks like it goes down first, then up, down, then up. So there's the waviness, as you can see down there. The sinusoidal function h models the distance between P and the floor in inches as a function of time t in seconds. The graph of h is and it's dashed midline for full cycles, 2 of them are shown below. 5 points A, B, C, D, E are labeled on the graph. No scale is indicated and no axes are presented. All right. Determine the possible coordinates for t, h of t for the 5 points A, B, C, D, and E. All right, so we are just creating any 5 points. It starts at the very top and comes down first. So that's exactly what happens here. So we could say that at the very beginning, we're 42 inches above the ground. This is where it gets gross because it rotates 20 times a second, which means the next time it hits the very top is going to be 1/20th of a second later. So 1/20th of a second later, we're at 42 again. So halfway in between that at C is going to be halfway in between 0 and 1/20. So half of 1/20 is going to be 1/2 times 1/20, which is 1/40th of a second. And at 1/40th of a second, we're at 18. Similarly, halfway in between 0 and 1/40th is half of 1/40th, so that's going to be 1/80th, and the midline was 30. D is going to be the confusing one. Every time we go from one point to the next, we can now see that it's 1/80th of a second. So I'm here at 1/40th. I need to find out 1/40th plus 1/80th is. And so maybe I multiply the top and the bottom by 2 here to get 2/80ths plus 1/80th, so you're going to be 3/80ths. And we're back at the midline, which is 30. So let's write those out. Okay, A could be 0.42. B could be 1/80th, 30. C could be 1/40th, 18. D could be 3/80ths, 30. And E could be 1/20th, 42. My age, believe it or not. Okay, so that problem, done. When an earthquake hits and creates a tsunami, the water first goes down from its normal level and then rises an equal distance above its normal level. What did I do here? Just scribbled accidentally? Gross. Then returns to its normal level. A tsunami is approaching Trig Island. Oh no! And is modeled by that equation right there. So, let's see if we're going to use a calculator at all during this whole thing, because that says no calculator. D is the water's depth, measured T time in minutes after the earthquake. This model only works for one cycle. Okay, interesting. No calculator, no calculator, no calculator. All right, I prefer that. I hate calculators. Using the equation, what is the maximum depth of the tsunami wave? All right, well, this is what we're given here. Okay, very, 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 very quick graph. We are going to be completely above sea level with that crooked line there. I have a midline of 11. I really don't like the fact that I made that line so bad. Let me fix it. Let me fix it. Let me fix it. Okay, better. All right, so my midline happens at 11. Okay, I max out 10 above, so at 21, and then 10 below, so at regular 1. It says it starts from the bottom, but this is a sine function, so that's not doing it, so okay. Oh, but you know what? All this left or right crap. Ugh. All right. Before I do too much, I have to move right 7.5, so it's actually going to start here at 7.5. Okay. And my frequency is 2 pi over 15. Okay, so if my frequency is 2 pi over 15, that means I have a period of 2 pi over 2 pi over 15. So I'm going to multiply everything by 15 over 2 pi. Lots of crossing out. 15 over 2 pi. You cross out, so my period is just going to be 15. So that 7.5 is actually extremely convenient, because 15 units later, right, it's going to repeat. So you're actually 15 halfway through, and then repeat 7.5 after that, which is 22.5. So it's a sine function. Did I hit everything? I did. It's a sine function that starts here, repeats here, so it goes through there, peaks out here, bottoms out there, and looks like U. Now, before you freak out, 7.5 is a half a period, because the whole period is 15. So you're just going to bottom out and do that. So there we can see that once this begins, it goes below like it said it would, and then come back up, like that. Okay? It says it only works for one cycle, but, you know, I drew a picture of 1.5 cycles. No big deal. Using the equation, what is the maximum depth of the tsunami wave? 21 feet, 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 meters. Using the equation, what is the normal depth of the water at Trig Island? Well, looks like it's 11 meters, because that would be the midline. What is the period of the function? Found it, 15. What does this mean in the context of the problem? That means it takes 15 seconds for it to go up and then down and then come back to normal. So I'm not going to write that out. So it takes 15 seconds to do that. Or you can say it takes 15 seconds to go down, then up, and come back to normal, because that's the way they want you to start out. So maybe that's the way we should say it. But 15 seconds to complete a cycle. Fun stuff. Last page. You are studying the motion of a simple harmonic oscillator that cycles every t equals 4 seconds. You have collected a table of values representing the height h inches of the oscillator above a reference point. The data is as follows. Write a sinusoidal equation. So I'm not using a calculator for this. Okay? Not using a calculator at all. What I will do is I will down here draw myself a nice little picture, though, and I think that'll help. So everything is above ground. Everything is positive. Everything positive time. We go out to 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going up to, what are the numbers that matter? 2.7, 7.2, and 11.7. Okay, we start out at the very top, so cosine, and then 7.2, and then 2.7, then 7.2, and then 11.7. Very similar to what we did before, where it looks like we have a period of 4. All right, 1, 2, 3, 4, 5. I need to scoot you over. No! Here. So what is this? 1, 2, 3, 4, 5, 6 is down here at 2.7. 7 is 7.2. 8 is 11.7, and then 7.2 to close you out. So let's draw that. Very cosine-y, like I said it would be, because it starts from the top. Could have done a much better job drawing it out, but you know what? How much do you pay for this video? Write a sinusoidal equation. I'm doing cosine because it starts at the top. So I'm going to compare this to, we'll do h. So h equals, and I'm assuming we want to do t as well for time. Yep. So h of t is going to equal a cosine b parentheses x minus c. Actually, it should be t minus e, close it, plus d, t minus c, close it, plus d, like that. Amplitude is going to be half the distance from the top to the bottom. In other words, from 7.2 to 2.7, so 7.2 minus 2.7, carry the 1, is going to be 2.5. 3.5. 4.5. Holy cow. 4.5. Ugh. All right, so h of t equals 4.5 cos. B is going to be the frequency. I know that the period is 4, so frequency is going to be 2 pi over 4. Which is going to be pi over 2. So we did one very similar to this already. I'll put t there, no movement left or right. Midline is 7.2, so there it is. There's my equation. Took a half an hour, but we got it. Predict the height at t equals 15 seconds. Now, I don't want to plug this into my calculator because that'll be a mess. Okay, so let's just use logic right now. Let's just use logic. I really don't want to use my calculator. 9 is 7.2, which means 10 will be the bottom, so 2.7. 11 will be 7.2. 12 will be 11.7. 13 will be 7.2. 14 will be 2.7. 15 will be 7.2. So 7.2 inches. And again, I could have thrown that into my calculator, typed in 15. This was much faster. How many times will the height be 2.5 inches off the ground in the first 8 seconds? Fortunately, I have a picture. Also, fortunately, I'm an idiot because the bottommost thing that this will hit is 2.7. So how often will it hit 2.5? How about never? Ugh. That was stupid. Oh, more? Okay. So I do need my calculator. Oh, I don't want to use it. All right. After the 10-second mark, is that the only time? I'm going to need it for D and F. All right. So let's go to our calculator. We'll type that guy in, answer a few questions. I don't like it, but I got no choice. All right, so let's type this guy in and see what happens. We've got 4.5 cosine. And then I like my fractions wrapped in parentheses, so that's going to be pi over 2, close it, x, close it again, plus 7.4, no, 7.2, that was a close one, that would change everything. All right, when I hit graph, not really accurate, so let's go to window. Since we care about everything happening after the 10th second, let's start the x minimum at 10. Period is 4, so let's just make the x maximum because we care about when it hits 9/11 after the 10th second, so it's going to hit it for sure 1. So we'll make u 15. Y min will set equal to 0 because it was like 2 point something was the minimum, and the maximum was like 11 point something. I don't remember. So we'll just set u equal to 15, and that should be a good enough picture for us. It is. Now 10 is right here. We care about when it hits 9/11. So y equals, let's make u 9/11 graph. So that's the first time it hits it. So let's find the intersect second, trace. Intersect is 5. Let's go just to the left of where it first intersects. Like right there. Just to the right of it. Always enter for guess. On 11.279. All right, let's go back and do it. All right, so after the 10-second mark, pretty quickly after that, at 11.279 seconds, we got our height to be 9/11. Graphically, what does h of t equal 7.2 represent? I'm just going to say what that means. That just means the harmonic oscillator is 7.2 inches above the ground. That's all it is. It's just 7.2 inches above the ground. Super simple, super simple, super simple. Now the next one is super stupid because I believe I said, oh, I need a calculator for this one. I don't. And here's why. Common sense says that this guy started out at 11.7 inches above the ground. Okay? The period's 4, which means 4 seconds later, same exact spot. 4 seconds after that, same exact spot. 4 seconds after that, same exact spot. So how much has it changed from 11.7 inches above the ground to 11.7 inches above the ground? Nothing. Nothing inches per second. So, good job, me. Good job, me. That'll do it, though. Make sure you go back to my YouTube and type out AP Precalculus 3.7, and you can watch some of my random videos. Half of these problems I made, half of them I found online. It'll help further your knowledge. But we are now halfway through the unit. And so watch some of my review videos because the next thing you probably have in your class is going to be a test. And so watch my review videos as well. Thanks for watching everything. Don't forget to like and subscribe. Bye!